Hi students, the third numerical problem. A jet plane is traveling towards west, that is from east towards west, at a speed of 1800 km per hour. What is the voltage difference developed between the ends of the wings? Having a wingspan of 25 meters, so the end to end wingspan is 25 meters. If the Earth's magnetic field at that location has a magnitude of 5 into 10 power minus 4 Tesla and the angle of dip is 30 degrees given. Though this problem appears to be very direct and simple, okay, but there is a small hitch in it. So we have to understand carefully. First, I will write all the given quantities. So the speed, okay, the speed V is equal to 1800 km per hour. So this is equal to 1800 into 5 by 18 meter per second. So kilometer per hour is converted into meter per second. So this 18 and 18 get cancelled. So this is equal to 500 meters per second in SI unit. Okay, what next is given? The wingspan, the length of the end to end length of the wings, that is equal to 25 meter, okay, 25 meter. And the magnitude of the Earth's magnetic field is given at that place. So it is 5 into 10 power minus 4. So this is 5 into 10 power minus 4 Tesla. And here the angle of dip theta is given as 30 degree. This is the hint. This is the hint they have given us. Actually, when will be an EMF induced in a conductor when it is moved in a magnetic field? When is the means when it is moved perpendicular to the magnetic field. So the vertical component of the Earth's magnetic field, which is responsible for the induced EMF, we have to consider. Though the value of B is given, we have to find out the vertical component of the magnetic field. So the vertical component of the magnetic field B vertical is equal to B into sine of theta. So that is sine 30. So this is now equal to 5 into 10 power minus 4. So 5 into 10 power minus 4 is multiplied by sine 30. So 5 by 2 is 2.5. Okay, into 10 power minus 4 Tesla. This is the only point you have to understand from this. So you have to find out the vertical component of the Earth's magnetic field at the place. Since the aeroplane or the jet plane is traveling towards the west, perpendicular to this magnetic field. Okay. Now, what is the induced EMF? The expression induced EMF, its magnitude alone. Magnitude alone I need. Okay. So induced EMF's magnitude is BV into L into the velocity V. Okay. This is B vertical. The vertical component of the Earth's magnetic field. BV into L into V. So what is BV is here? We have to substitute. Therefore, EMF is equal to, or the voltage difference is equal to 2.5 into 10 power minus 4. 2.5 into 10 power minus 4 multiplied by the length. Length is 25. So this is 25 into the velocity is 500. So this is 5 into 10 power 2. So I can multiply by easy methods. So this also can be written as 25. Okay, 2.5 is written as 25 into 10 to the power of minus 5. Okay, into again 25 into 5. So 25 into 5 also can be written as what? 125. Okay, so 25 into 5 I am writing as 125 into 10 power what? 2. So that this is equal to 125 into 25 I am going to multiply. Okay, using a calculator. 125. So 125 into 25 is equal to 3125. The product is 3125. Here it is 10 power minus 5, here 10 power 2. So the product is 10 power minus 3. So this is 3.125 volt. So which is the relevant answer here is 3.1. So this is nearly rounded off to 3.1 volt. So we have got the answer. The voltage difference E is equal to 3.1 volt. Therefore, the option B is the right answer. Okay. So this is how we have to handle the problem. In some of the numerical problems, directly they will give the vertical component. The vertical component of the Earth's magnetic field is 5 into 10 power minus 4 Tesla, means once again you need not multiply by sin 30. Purposely they will give the angle of dip also to confuse us. So keep in mind the vertical component of the Earth's magnetic field is given here. That only has to be converted, understand, into vertical component, and you have to do it. Otherwise it is a simple numerical problem only. I hope you must have understood well. Fine.